Welcome to Spring LIB.
Okay, so up top we'll have an example of an E1 reaction. Okay, bromine would leave, generating a carbocation, and a water molecule could come along and act as a base and deprotonate a carbon on a neighboring carbon, picking up the hydrogen, leaving behind the electrons, and generating this alkene. Right, so that's E1. And now we'll see E2. So it could be a similar reaction. Really could be the same substrate. But in this case, we'll have a strong base, let's say a hydroxide ion. It's going to come and steal this proton. The proton's going to form a double bond, or the electrons between the carbon and the proton will form a double bond. And bromine will be kicked off. And we will form an alkene via an E2 reaction. What are the characteristics that tell us that this is an E1 reaction? Tertiary substrate, reaction, because it generates a carbocation, it's basically got to be either tertiary or secondary. So tertiary makes E1 possible because of the stability of the resultant carbocation. And then the other property of this reaction that tells us it's going to be E1 and not E2 would be the fact that our base, in this case water, is a somewhat weak base, right? That is, this base will not attempt to deprotonate a proton before our carbocation is formed. It's going to wait around until the carbocation is formed and then come through and steal a proton. Okay, and in contrast to that is E2. And pretty much the only thing about this reaction that tells us that it is definitely E2 is that we have a strong base. And that strong base is not going to wait around for bromine to leave before it attacks and steals this proton.